Okay, broadcast started. Please chat in. Start a YouTube live.
All right.
With the YouTube live. 今何人ぐらい見に来てる？まだ全然来てない。
Now 31 people waiting.
Yeah, 31 people are already watching us.
Cool. Should we start?
Until
No.
until 7 p.m. GST. Yeah.
Okay, no problem.
Yeah. We should do chatting a couple of minutes.
Happily.
So your study today includes the Kubernetes and Spring Boot and Spring Cloud?
Sorry?
Your session of today includes the Kubernetes and Spring Boot and Spring Cloud?
Yeah.
Yeah.
And Spring Data and Spring GraphQL and Spring Spring Native and yeah, lots of stuff.
I see. As always.
Build packs, RSocket. You know.
Oh, really?
Yeah, lots of stuff.
RSocket.
Oh yeah.
I'm looking forward to see it, watch it.
Thank you.
Hi.セロさん、背中の後ろ側にあるもの何ですかそれ？白じゃない。背中の後ろに見えるやつ。
段ボール？
段ボール。なるほどね。
アスマタワーって言うんですけど、アスマートから送られてきた段ボールを開封せずに積むことをアスマタワーって言うんですよ。
初めて聞いた。なるほど。
アスマタワーで、その下プレステ3ですね。プレステ3がちょっとだけ見えてるね。あと一番上にね、これ映画のパンフレットが袋に入って載ってるんですけど、
はいはい。
竜とそばかすの姫です。
どうでした？
あれ見てないんですか？
見てないですよ。映画館に行ってない。
あれはもう日本国民が見るべき映画ですね。
マジか。
まあ、世界中の人に見てもらいたいけど。全然面白くないストーリーを音楽だけで泣かせるっていうすごい作品でした。
それはすごい。CD だけ買おうかな。
でもいまいちでした。
なるほど。
はい。ではそろそろ時間になりましたので始めましょうか。こんな話しておいてないですか？
そうですね。
はい。今日は何だったかな？クラウドネイティブ、Kubernetes ネイティブ Java ですね。で、ジョシュ・ロングさんにすごい量のスプリングクラウド、スプリングブート、グラフ QL、スプリングデータ、あと R ソケットとか、グラル VM を使ったスプリングネイティブとか、いろいろ含めて、すごいたくさん話してもらうので、私のこの前説なんて短ければ短い方がいいので、これぐらいにして、今日はもうジョシュさんに話してもらいましょうか。
そうしましょう。
はい、じゃあ始めましょう。So, Josh, please start your session.
Thank you. First, everybody, I appreciate you coming here today. I am so sorry that I could not make the last 2 different events. I had COVID. My brain wasn't working. I am very sorry. I am so sorry to have disappointed and to have failed to be there when I said I would be there. I don't do that normally, and I hope I don't do it again. Anyway, thank you for coming tonight. I'm very sorry about that last time. All right, my friends, we have about 90 minutes, so that's not a lot of time. We have a lot to cover and very little time in which to do it. Today, we're going to talk about building software intended for production. And these days, more often than not, production is Kubernetes. And so we're going to talk about what it means to build Spring applications that live and breathe in that environment. But keep in mind, Kubernetes is a cloud. It's a platform that allows us to build quickly. It allows us to take advantage of the dynamic nature of the cloud. And when you take advantage of that dynamic nature, some things start to become clear. First, it's easier to move new ideas into production if you have small services. These are microservices, right? Because you have small teams, small code bases, etc. So microservices have their own complexity. They're harder to scale. They're harder it's harder to integrate. And so there's these complexities that you have that come from building distributed systems. And so I talk to people about reactive programming. Reactive programming gives me a way to address some of that complexity. It gives me solutions for 3 things. One is how easily can I reuse my infrastructure, my resources on the JVM. Things like threads, right? Threads are, for the moment, today, with Project Loom, this changes, but for now, threads are expensive. It also gives me a way to be consistent, right? I have one programming model that I can use to talk about all the different kinds of data. If it's coming from RabbitMQ or Kafka or REST or RSocket or WebSocket or GraphQL or whatever, it's all the same kind of stuff. And so it doesn't matter if it's a small amount of data, a huge amount of data, slow data, fast data. It doesn't matter. It's all just reactive streams. And this makes your life much easier. You don't have to create different APIs just to work with this kind of data. And then finally, because we have one thing, we have one type of data, a reactive stream, we have a third benefit, which is when we need to introduce reliability patterns, things like retries and circuit breakers and back pressure, then we only have to do that one place in the reactive stream. And it's the same mechanism, it's the same facility that we can use for all of our APIs. So this is a big deal. It makes building cloud services much easier, much more productive, and much safer, and it takes less lines of code. I'm a big fan, okay? So these things are all about building software intended for production. It's all about building software that works well in that production environment. And so today we're going to talk about a lot of these different things that I think you need to care about when you start to care about production, and especially when production is Kubernetes. So as always, we'll build some new software by going to my second favorite place on the internet. My first favorite place on the internet, of course, is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. But if you have not been there, you can begin your journey here at start.spring.io. And we're going to build a new service called Customers. I know that the talk is called Kubernetes Native Java, but I should have called it Kubernetes Native JVM. I'm going to use some Kotlin. Maybe later I'll do some Java. It doesn't really matter, but Kotlin to me is very natural. You can use Java. It's fine. Use Java if you like. Actually, I'll use Java for this one. How about that? And we'll do Kotlin later. That'll be easier. I'm going to use Customers. And I'm going to bring in some dependencies here. I'm going to bring in R2DBC, which is a reactive relational database connectivity abstraction. We'll bring in H2, which is an in-memory SQL database. We'll bring in Lombok, which is a compile time annotation processor. And we're going to bring in the reactive web support and the Spring Boot Actuator and the Spring Native project. All right, so let's hit generate. And we're going to open this project up. in our IDE. So UAO customers, and we'll just install it right there. And it's going to open up inside of my IDE, IntelliJ. I'm just making sure that it's also downloaded all the current packages. I don't know why, but IntelliJ has been very confused recently. I get these errors now whenever I open up IntelliJ. So,
Hi, Josh.
hi.
Can you share the screen?
Oh, I knew I forgot something. Share. There you go. Okay, good. So I went to start that Spring Demo and I added these different dependencies to my project. And now I'm loading the project in my IDE, like so. All right, so we're going to build a new application. And this application is going to manage data related to customer records. Okay, so private integer ID, string name, and it's going to be persisted into the database. No args constructor. All right, there's my entity, and this entity is going to, I'm going to be able to read and write instances of this entity. So I'll create a reactive code repository, integer, and then I want to create some sample data, right? I want to have data in the database, and I want to read that data from a REST API. So I'll create a REST controller, class customer. Actually, you know what? Just to keep it more consistent, I'll say response body. There you go, customer REST controller. Good. And there we are. And I'm going to create an endpoint that returns the customer data. So customers, and I'm going to return just a reactive stream of customer data. All right. And I'm going to, in order to get that data, I'm going to inject the customer repository, like so. Find all, and you know, we need the constructor, so I'll use Lombok to create the constructor. Lombok will make that work a little bit easier. And now I need to actually put the data in the database. It's an in-memory SQL database. So I'll go to the resources directory. Hello, come back. My IDE said no. We'll go to the resources directory here. I'm going to create a file, a directory called we're going to create a file called schema.sql. So create table, customer, ID, serial, primary key, name, varchar 255, not null. Okay, so there's my basic schema, and I want some sample data, so I'll put this in as well. So data.sql, insert into customer name, and we're going to put some people. Let me see, some people on the Spring team. Dr. Sire. Let's see, Maki, there we go. There we go. And we're going to have, who else is on the Spring team? We've got Olga, we've got Violetta, we've got Yushin, we've got Stefan, of course, and we've got Jurgen, and oh, me, I'm on the Spring team. So what is that? That's 16 records. That makes me think that there are 8 total. So there we go. There are some people. Let's go ahead and start this application. It will run on a port 8080 by default. Okay, so we can start this. Okay, so now, localhost customers. There's our data. It's worked. We have 8 records. It's a very simple API. Good. So now we don't have to worry too much about that. Are we ready to go to production? No, of course not, right? There are things that we need to do to take this application to production. Having data and having a REST API isn't interesting. You still have work to do, right? So one thing that we want to support is observability. And we can support this through the Spring Boot Actuator, right? Spring Boot Actuator gives me a set of managed HTTP endpoints that give me information about the state of the application. I want to expose all that information so that we can see it, because it's not visible usually. It's locked down. But for our demo, I wanted it all to be visible. I'm going to health. I'm going to show the health details. I'm going to show the Kubernetes probes. These are for Kubernetes, right here. Probes, right there. And I want to go up here. I want to also show all the health details, all right? So let's go ahead and restart this with those changes there. Okay, and can I move this out of the way? There we go. Good, so, why doesn't it refresh? Good, okay, so there we go. There's my browser, and we say we want to go to, I want to hide that, good. I want to go to Actuator, and when I go to Actuator, I get a set of HTTP endpoints that gives me information about my service, right? Things like the beans endpoint, which tells me all the Java objects and how they are wired together in the Spring world. We have caches, so if you have the cache manager, it shows you all of that. You have health. Health tells you all the subsystems, all the pieces of your application that might fail. And if they fail, then your application is sick, right? So we have an R2DBC database connection to a SQL database. We have our file system, right? All of this could become sick. And if that happens, then our service is no longer going to work. So it says up, it says 200, HTTP status 200, but this stuff could go down, and you could change this. We'll come back to this in a minute. And we'll also revisit liveness and readiness probes. These are for Kubernetes. We'll talk about those in just a second as well. Okay, so we have the health, we have info. Info is empty. You can put identifying information in that endpoint. This endpoint is great if you want to know what service is running, what the name of the service is. If you're doing continuous delivery, with continuous delivery, you take code and you deploy it straight to production. You do tests, you do integration, all this kind of stuff, but you deploy directly to production. You don't wait for everybody to, integrate and stabilize. You just, every single git commit results in a push to production. And so it's very important, if everybody is going to production, that you have some way to identify what service is running there. And this is a great thing to use for that purpose. Right, so you can say info dot, message, right? Hello, JJUG, right? There's my message. And I can leave that there if I want. But I can also put information about the current build. What Git repository am I using? And I can do this by configuring a plugin. It's already configured for me, actually. I don't really need to do anything. I just bring it in. So it's called the Git Commit ID plugin. I don't need to specify the version. And once that's there, it'll now analyze my project when I do a build. So I'll say git init, git add, git status, git add. I'll say git commit -a, YOLO. Okay. So now, my Maven skip tests clean package. Okay. It's using this plugin. Did it not? Git commit ID. Go up here, Git commit ID plugin. Okay, maybe I just need this as well. All right, so I can put that there. And this property is defined in the parent pom.xml, so I don't need to redefine it, thankfully. But I could redefine it and use a newer version, for example, or an older one. Okay, so it's downloading, it's building everything. And you can see that it's creating a directory here and creating a file. Oops. Where's my file? There. So reload from disk. There you go. Generated sources. Where did they put it? No, it's not there. Org cd target find iname get.properties. Oh, I put this in the wrong plugin. There's a profile in here now, and the profile is it hides the plugin, so it didn't run. Okay. Oh yeah. Okay. Build plugins. Okay. Wait for it to go. Classes. Yeah. Where's my get.properties? Reload from disk. Has something changed? Am I doing something very wrong? Let's see. Maven skip tests. Huh. Well, something is different. I don't quite know what has happened, but get commit ID plugin. I need to do something special. Looks like that's already there, right? So this is the plugin. Oh. Yeah. Third time. This will be okay. There we go. See, it's calculating all this information, the get build, get commit ID, all of that is being determined by the compiler, by the plugin, and we'll reload from disk. And we can see there's a property file here called get.properties. And now with that built, I can restart my application. Okay. And you go here, and there's my message from earlier, but there's also identifying information about the current build. Okay, so that's another very useful endpoint. You've got conditions, which tells you which Spring Boot conditions have been evaluated. You've got the config props endpoint, which tells you which properties apply to the current Spring starters, the Spring Boot starters, and what properties they have. So for example, earlier, I set management.endpoints.web in my property file here, management.endpoints.web, exposure.includes asterisk. So exposure include asterisk, right? So you can see the configuration and the property values and all that. Very convenient. You've got env, which shows you environment variables and properties on your in your application, but it also shows you, it doesn't show you secrets, right? So like, for example, my client key secret is masked, right? So things like this. Okay, so you've got a lot of different interesting information here. Metrics gives you identifying information. This gives you aggregate values, right? Statistics, the sum, the median, the count of certain things in the system, right? Things that have a lot of data that you want to create a simple sample of the data, a very simple representation, and so you can use the Micrometer project, right? Micrometer it's a facade for metrics, and you can use it to publish these metrics to time series databases like Prometheus, which is very common in the Kubernetes environment. Okay, so we have all these different endpoints, and they can all be customized. They can be changed. So for example, let's suppose that I want to change the health endpoint. Well, I can do a few different things. I can create a health indicator if I want. I can create my own. The contract is really simple. health.status I art JJUG build. There we are, okay? Health indicator. And so I'm going to create my own custom status. This is one way to create your own custom status. The other is to, yes, I do. The other is to, let's just say, post mapping, mono void down. Okay. And what I want to do is I want to application event. Let's see, what is it? Application prepared, whatever, something like that. Oh, there's a way to publish an event in the application context, but I forget how to do that. But the point is you can change these things. So okay, let's go back to health. There's my custom health indicator, right, with my custom status. If I let's forget this for now, we don't need it. If I want to, I can put some sad, down, right, or out of service or whatever. And that represents that will represent the state of the service, and that will signal that this is down, and that will trigger a 500 status error code. And this is important because if you are putting your application in a cloud, that cloud needs to know if your service is sick. Kubernetes needs to know if your service is sick. There are two ways to tell Kubernetes about whether your service is healthy or not. One is the Readiness Probe. The Readiness Probe tells Kubernetes whether the service is ready to start serving requests. Okay. The Liveness Probe tells Kubernetes whether the service is still able to serve requests. So they are both related to the life of the application, to the health of the application. Okay. But obviously, they are different parts of it. And so this information you get for free, this Liveness and Readiness Probe, and you can configure these probes in your Kubernetes descriptor. So now I have an application. What happens if the application gets, what happens if it's sick? What happens if it's not healthy, right? What if the service becomes sick and then suddenly it needs to be taken out of the load balancer? Well, when this happens, the container orchestrator, Kubernetes, has two choices. It can kill your pod immediately, or it can wait until you have finished some of your work, okay? And this is configurable. Usually, you have sig term and then sig kill. Sig term is the signal that gets sent to your process that tells your application to prepare to shut down. And then sig kill is the force. It forces your process to stop, right? It's the operating system, kill -9, that kind of thing. Usually, sig term and then sig kill happen almost immediately, same time. But you can actually have a little bit of a window, a little bit of time in between this, and that's called graceful shutdown. So you can say shutdown. You want it to be 30 seconds, let's say, and you can say, let's see, you can say server.shutdown equals graceful. Okay, so in this case, this will shut down gracefully, and it'll wait 30 seconds. You must configure this same setting in your Kubernetes manifest. But now, when your application is about to be shut down, when the container orchestrator is about to stop your pod, it'll send sig term. Your application, your Spring application, will see that it's being asked to shut down, and it will run all the finalizers, and it'll give you time to clean up your work, to clean up any in-flight transactions. During this time, Spring will no longer accept incoming HTTP requests. So no new HTTP requests. Only the existing ones will be allowed to continue and to finish, okay? This is very useful because it means you can clean up your state. It's not a violent, shutdown, okay? So once it's shut down, once you've got this all configured, you've got your probes, and your probes impact whether it gets shut down or not, right? You've got all this information. I think it's now a good time to take the application into production. And so obviously, for a lot of people, this means Docker, right? It means using Docker to containerize the application. Don't freak out. Don't worry, it's okay. Docker, obviously it's no longer the only way to do it, right? What we want is a container. So there's actually a standard. There's something called OCI containers, which are, thanks to Docker. And what we want is to turn our application into a container. You could create a Docker file and then just, do Docker build on the Docker file, and that will create a container. You could also use a third-party plugin. There's some very good ones out there. Spotify, for many years, has had a Docker Maven plugin. There's also the JIB, J-I-B, Maven plugin from Google. That's also very fast, very nice as well. But my favorite one, my favorite approach is to use something called build packs. Now, build packs are a way to take your application code and turn it into a container. And so it doesn't matter what kind of application, right? You can use Java and Spring Boot. You could do a .war, like regular Tomcat or something like that. You can do Node.js or Python or Ruby on Rails or .NET or whatever, right? There's build packs for all these different languages. The history of build packs is very interesting. The work that was done by the Heroku, Heroku, and Cloud Foundry teams eventually merged together, and build packs is the result. It's the collaboration between the Cloud Foundry and the Heroku teams, okay? So build packs are the standard. There's an implementation called Paketo, and Paketo is a build pack project that has working builders for different languages. And so if you want, you can just do pack build. You can say terminal. You can say pack build, I think it's this one. Pack build path, something like that. Let me see. I never do this. Pack. Okay, yes. Pack build my app dash path. Something like that, okay? And that will actually look at the directory. It'll look at the project. It'll look at the source code. And if it's a Ruby on Rails project, it'll say, oh, this is a Ruby on Rails project. If it's a .NET application, it'll say it's .NET, and it'll figure out how to run it. It'll download it for Java. It'll download the JRE. It'll download the latest security patches and all this, and it'll create a container. And that's fine, right? It's very convenient. You can even go further. I'm not going to run all this. It takes another minute. You can go further. Instead of using pack directly in your build pipeline, you can actually run something called kpack, right? So kpack, build packs. Kpack is a cloud native build pack, basically. It's a module that we donated, that we built, where it runs inside of Kubernetes, and you can tell it to monitor your source, your Git repository, for example. It'll monitor your Git repository, and whenever there's a new Git revision, it'll automatically create a new Docker image from that revision for you. And then you can then test that and deploy that if you want, right? So this is automatic. Now you have just one installation. You define this just once in your cluster, and then now all of your Git pipelines, they can all use the same machinery in your Kubernetes cluster. Very convenient. I like to generate my containers when I build my application. And if you like using pack, it's a separate command line, then you might like the Maven plugin. The Spring Boot Maven plugin has built-in support for build packs. So we don't have to do anything special. It's already there. But I'm going to comment out something here because it'll get in the way for a second. I'm going to comment out all that, okay, and all of this as well. Good. So now the Maven plugin, you just say skip tests, clean package, Spring Boot build -image. And what I want it to do is I want to define the image name for my application. So I'll say spring-boot.build-image, dot image name equals, and then here we wanted to give it the actual image name that we're going to use. You can do this later. You don't have to do this now. You can just do build image and then do Docker tag, right? It's the same thing. But I will do it now because I just want to get it done. So I'm using the Google Container Registry, right? And so I want to be able to Docker push this to my Google Container Registry. You can use VMware Harbor, which is awesome. It's very, very usable, very, very powerful. But I don't want you to think that you have to use VMware stuff. I love VMware technology, but you can use all, it's just open. All of this is nice and open. So you have an image name. So gcr.io, my repository is beautiful. I'm going to call this customers latest, okay? So let's run this. And it'll sit in the background, and it's going to create a container for us from our application. So this will take, like I say, about 1 minute. And this is desirable because now we'll have a Docker image. All we have to do is then Docker push, right? That'll take the container that's in our local machine and push it to our container registry. Now, obviously, okay, almost there. Look at that, very quick. Come on. You can see it's downloading all the builders. There we go. About 50 seconds to build that, yeah? So there's my image, and I can do Docker run -p to expose the ports. Or better yet, let's say I do custom port, right? I want to use an environment variable. So I can say -e server _ port equals 8081. And then there's this, okay? So it'll start up, and I can go to my browser, localhost 8081, and there we go, right? So now we have a simple application that's ready to go to production. So Control-C, no problem. Now I want to be able to Docker push this. So this was Docker push. Okay, Docker push, oops. Okay, and then from there you could very easily create a Kubernetes deployment, right? And that's not hard. I'll do that here as well. So right now, get pods, right? There's nothing there. Get pods ncnj. My Kubernetes namespace is empty. I have a script that I wrote here, deploy customers, and this script looks like this. It's going to create an app name. It's going to create the, we're going to call this customers, and it's going to do the same thing I already did. I don't need to do this again. That'll already be done. And now it'll do Docker push, and then it'll create a deployment, save the Kubernetes deployment there. It'll create, it'll expose it to create a service, and then I'll do port forwarding so I can access the service on my local machine, even though it's running in the Kubernetes cluster. So let's run this. And over here, you can see this is already done. So this will take, service, get service, says ncnj, delete service customers, and it's ncnj. Okay, get pods. There's that. Let's just see what happens now if I run this one more time. Okay, it's up and running. Localhost 8080 customers. Right, so do I have this running locally? I don't think I do. This is not running here. Good, okay. So there you go. This is now the this is the instance of my application running in Kubernetes. We can hopefully confirm as much by looking at the environment. Okay, so it's Paketo build packs, right? So all of this, and these are the environment variables you get from Kubernetes, right? So there we go. There you go. Kubernetes port, blah, blah, blah. So I'm running now in production. That's not hard, right? This is easy. It's very powerful. I think the hard part is the Docker file. I don't like having to build the Docker file. Build packs makes it so I don't have to worry about that. So now, my friends, I have a service that's in production, but we can do better, right? We can do much better. There are several things that we can do to improve this. First of all, I want my application to be more performant, more robust, more efficient. And one way to do that is to use GraalVM. GraalVM is called a ahead of time compiler. GraalVM takes my code and it analyzes the code and it turns everything that it finds into an architecture-specific binary. So if you're running on Linux, it'll create a binary that only works on Linux. If you're on Windows, it only works on Windows. It gets rid of everything that is not being used. Or really, it tries to get rid of everything that's not being used. But it's not sure. It cannot know for sure, right? It has confusion sometimes about what is being used. And the reason it does not always know is because it does static analysis. And so when it looks at the source code, it sees that you're trying to remove, it says that you're doing only certain things. It can only do static analysis. It cannot see that you're doing some things that are dynamic, that happen at runtime. Things like reflection, things like loading a resource file, from a jar, like a class path jar file, like a JPEG or something, or a property file. It can't see that. It doesn't know about that. It doesn't know about proxies, JDK proxies. It doesn't know about cglib proxies and Spring. It doesn't know about lots of different things that lots of different Java applications use. And so we built a project called Spring Native. Spring Native provides configuration so that when you compile your application, we have given it a clue. We have told the compiler about all the different dynamic things that you are doing. And so you can use GraalVM directly. You can just create you can build an image. Let's Control-C this here. So I can do Maven -p native, okay, clean package. And by the way, that's this profile down here, right? Profile native, right? It automatically enables the GraalVM compiler and sets up the native image, Maven Plug-In, and all that stuff. So I'm also going to skip tests because this also runs, it compiles your tests and then runs all that in the test first, and then it compiles the main code and compiles that and runs it. But the problem is that because it's doing all this analysis on everything, including all the jars and all the source code, all the jars and source code, it takes a long time. It can take several minutes, like 4 or 5 minutes sometimes. It's very, very painful, very slow. So I don't want to compile the tests and then have to wait another 5 minutes for the production application. Okay, so we're going to let this work in the background. I have the GraalVM compiler on my local machine. Okay, I like the GraalVM compiler, but not everybody has this, right? Not everybody has the GraalVM compiler. And so what we have here in Spring Boot is a, where did it go? Here we go. We have configured here for the build pack integration, a native image support. And so if you want, you can use the build image command and it'll download GraalVM inside of Linux, inside of a Docker image. And then in that image, it'll compile your code into a native image and create a Docker image that has a Linux binary inside. Isn't that cool? That's really cool. Like it'll actually create a Docker image in Linux on your Mac, right? So I'm doing this manually. I'm compiling it directly here, but you can also use build packs. In fact, if you want to use the build pack support, nothing changes. You just go to start.spring.io, and as soon as you add this, then it's configured for you. You're done, right? That's all you have to do. So I think that's really powerful, right? I'm showing you, you already saw how to do build packs. I'm going to show you just how to build an image directly here on your local machine, okay? In the meantime, while that's running, there's other things that we may want to do, right? There's other things that we may want to have happen that are specific to my environment. And so, for example, one thing I might want to do is have configuration. Here, it's on port 8080, which is fine, right? My local machine is 8080. But what if I want to have something that runs only on a certain port, or sorry, only on a, what if I want to have, like, for example, this message? What if I want this to be different when I run in Kubernetes, okay? So in Spring Boot 2.4 and later, you can do dash, hash, dash, dash, right? And here, you can say you want to have configuration that is activated on Kubernetes, right? And so when that is true, the message will be hello Kubernetes, right? And so don't listen to IntelliJ. IntelliJ doesn't know what's wrong. It doesn't need to know, right? But there's nothing wrong. This is actually valid now. So you've got one message by default, but you've got another message that will be used only when you're inside of Kubernetes. Now, you can force your code to think it's in a different platform by specifying that configuration. So I can go here, I can say environment variables, or sorry, program arguments, dash, dash, apply. So now, let's restart this. Okay, come on. All right, so now I go here, localhost, actuator info, and it says, oh, I'm running inside of Kubernetes, okay? Now I go here, get rid of this, apply, hit OK, and of course it'll go back to having only working there, right? Now, I can also do dynamic things, you know, that only apply in my Java code. So I can say conditional on cloud platform, right? Here, cloud platform dot Kubernetes, right? So I can have a health indicator. And this health indicator can be health.status I heart Kubernetes or something like that, right? So I can have, you know, Kate's health indicator, and just it's always true, but this is only true in Kubernetes. So let's go back here, and you know, program arguments, apply, restart, OK. Compilation. Oh, there we go. Oh, did I do something wrong? No. I don't know what's going on. Okay, so hello Kubernetes, right? And then health. You know, it says JJUG and I love Kubernetes, right? But if I change this, then we will not see that custom health indicator. So you can do dynamic configuration for properties and for Java objects. This is very useful because there are different ways of reading configuration, right? You might store your information like your, you know, what port do you want to run? You know, if you've used Spring Boot, then you know that that configuration can come from different places. It can come from environment variables, property files, and if you're running inside of Kubernetes, you can create config secrets and config maps. A config map is like a dictionary. It has keys and values. These values can be mounted as environment variables in your container, in your pod, or they can be created as a file system called a config tree, okay? And so let's say that I'm running inside of Kubernetes, by the way. Oops. So off, up. I don't know what happened there, but okay. Oh, maybe it's that. I added a space. Anyway, that configuration can live in something called a config tree. Okay, so we'll come back to that in a second. That config tree is a directory. So I say make dir config cd config. I'm going to say echo 9191 server.port. Right, cat server.port. So there's my config tree. There's a property. There's a file called server.port that has a value. So now let's say I'm running inside of Kubernetes. I want to import that config tree. I can say config tree home desktop config. Okay. So this is only going to exist in Kubernetes. Let's go ahead and restart that. Oh, I don't know why that's not showing everything else, but it doesn't matter. Okay, go here. Get that back. Start. And so the port, it'll be overridden. It won't be 8080. It'll be whatever we put here, 9191. So, okay, it's no longer 8080. 9191. Okay, so we have Kubernetes, I love Java, JJUG, and there we go. So now we have the ability to draw our configuration from config maps that are created as environment variables or config trees. And we have the ability to do dynamic configuration based on whether we're in the cloud environment or not. All right, so we have our image here. Go to the target directory, customers. Okay, whoops, that was weird. I don't know why that one was so slow. There you go. There you go. So usually it's about 0.15. Maybe it's right now I'm streaming. I'm sharing my screen, so that's going much slower, right? But whatever. There's our application now, our customer service, and the service is on port 8080. So I'll stop this one here, and we go back here to 8080, and there's our application running in GraalVM as a native image, okay? Okay, so now, my friends, we've looked at configuration, we've looked at dynamic configuration, we've looked at build packs and Docker images, we've looked at building a simple reactive REST API that talks to a database, we've looked at observability and different things you can do to make it more robust in that respect. Let's now build another service. And this other service will be called the order service. And in order to create it, I'll use Kotlin. And we're not going to use HTTP. Instead, we use RSocket. Now, RSocket is a binary protocol. It was created by engineers at Netflix and then Facebook. They left Netflix and then they went to Facebook. RSocket is designed to get past some of the limitations of protocols like HTTP and gRPC. Okay, remember HTTP 1.x has several very bad limitations. First of all, it's text-based. It's not binary data, and so it's very inefficient over the wire. Second of all, it's client-server based. So you have a client that makes a request to a server, but it's not truly bidirectional. The other thing is that connections are not reused, not efficiently, right? This is improved. A lot of this is better in HTTP 2, but still, you still have end of line issues for what happens if you have a lot of things that are being requested in batch. You have protocols like gRPC, which want to make HTTP 2 more appealing, more useful, but even there you have problems. Everything must be Google protocol buffs in gRPC. So these limitations make it so that it's not flexible enough for people who are trying to build services that are very quick. Also, they're not natively reactive, right? Reactive programming gives you something called back pressure. Back pressure is the ability of a service to push back the overflow of demand, right? So if the service is being overwhelmed, if too much traffic is being sent to the service, back pressure allows the client to if too much demand is being sent to the client can then say, I cannot handle anymore. No more, thank you. And this allows the client to, work at a speed that is safe for it, as opposed to too much data. Okay. So this is an RSocket service, And our service will be a very simple one. We have customer service data over here. I want to create an endpoint for our socket order service, right? And so, you know, you have customers. Customers have orders. So maybe the orders are part of the customer aggregate, right? They're part of the same aggregate type in the bounded in the domain model, right? That's probably true. Maybe the orders should live in the customer, but you know, even if you delete the customer data, you still keep the order data so that you have a record of all the money that has been earned and saved and so on. So it's useful to have you know, both services, different services. I'm not going to bother setting up a whole database and all that. Let's just create an RSocket service here. RSocket controller. Okay. And I'm using Kotlin, which is very similar to Java. Hopefully you can recognize that this is a Spring Boot application. This is a function. It's public static void main. It takes an array of strings. And this is a controller. We're going to start the application. Import 8181. And I'm going to create a constructor. And in this constructor, I'm going to create a concurrent hash map. Okay. And the hash map will have integers and order data. So the orders are a class, right? So we'll have the, we want to have the ID, and we want to have the customer ID. The problem with this code is that it's very Java-like, right? We can do better. So instead of doing all the extra work, we can just use Kotlin's nice, elegant syntax, right? So this is cleaner. And we don't have getters and setters and toString yet, but if you add this, you'll get getters and toString and all this. So now I want to initialize some random, you know, some fake data, okay? So I'm going to say 0, I'm going to do a range. So from 0 to 8, okay? Remember, in the customer service over here, we created 8 records, right? How many records do we have? Oh, here, right? There are 8 different records, right? So the IDs will be 0 to 8, or there'll be, you know, 1 to 8. So 1 to 8, okay? I think it's 8. I think I'm not sure if this is inclusive or exclusive, but we'll try, okay? So print the customer ID is, okay? And what I want to do is then create a list of orders. So I'll say 0.math.random times 1,000 .toInt for each. Okay. So I'm creating I'm creating a random number of records. Let's just do 100. And for each one of those, actually I want to map each one of those, each number, into a new order object. So customer ID, and then it. You know, this will be the order ID. Say that. Okay, and that gives me list of orders. Right, that'll be a list of order. Good. And so I want to put each list of orders in the database. So I'll say this.db, and it'll be customer ID equals list of orders, and voila. And there's our custom list. So that's just a very simple constructor just to create some fake data so we have something to work with. And now I'm going to create an endpoint. And again, it's similar to what we did for REST and for HTTP. I'll create a message mapping endpoint instead of a get mapping. And I'll say that, you know, or get orders for, and instead of using a path variable, we'll use the destination variable. And I could create a response. I could create a function that returns the body like this. I could define the body like I would in Java. I could say it's going to return a stream, a reactive stream of orders, and I could say return this .db customer ID, and I could, that's a val list, and I could say return a flux, from an iterable, right? What's the issue here? Stream from stream. I could do something like this if I wanted to, but this is very verbose, right? Because basically this is just one expression. There's no need for this. And so this just seems like a lot of waste. So Kotlin is very nice. I can just get rid of all that, and that becomes the same exact thing, right? The compiler figures out what's supposed to happen there. Okay, so there's my RSocket service. It's going to run on port 8181, and now it'll start up. Okay, now our friend Toshiaki Maki, he is awesome, and he built a great client that you can use to talk to this RSocket service called RFC. So localhost 8181, the route will be orders dot, let's say 2, and the exchange type will be a stream. So now I've asked for all the customers for this order. I've asked for, oh no, it's the other way around, isn't it? I did the wrong thing there. Val. That's better. Okay. There we go. Much better. So now I've got all the customers, and each customer has a different number of orders. Okay. So now we have 2 different microservices. One using HTTP and Java, one using RSocket and Kotlin. And now I want to talk to these different microservices. And this is one of the benefits of using an API gateway. Gateways are a great place for outside clients, like your iPhones and your Android devices and your PlayStation and your HTML devices. All these things can talk to your downstream microservices through the gateway. They can translate requests, they can do security, they can do rate limiting, and so on. So I'm going to create an edge service, and I'll use Spring Cloud Gateway. I'm also going to use RSocket and the reactive web support. I'll use Kotlin as well, and we're going to go ahead and hit generate. Okay. One thing that I want to do is I want to actually have this. Let me throw this away here. Show in Finder. I want to have the snapshot and milestone repositories on the class path. So I'm going to use Spring Boot 2.6 milestone. Okay. So we'll hit. We're going to generate that instead, and I'll switch it back to Spring Boot 2.5, but not. I just want the milestones. That's it. That's the important part. So UAO edge. Oh, I've also forgotten to add gateway, didn't I? Yeah, I have gateway. Good. So let's go back to my code. 2.5 what? 2.5.4. Okay. So 2.5.4. All right. Okay, so let's build an edge service. And the first kind of edge service, like I say, is a gateway. And we can use Spring Cloud Gateway to make it easy to introduce these cross-cutting generic kinds of concerns. So class gateway configuration. Come on. Right, so it's a bean. And I'm going to use the route locator builder to build the bean. Good. So we'll say rlb.routes. And there's a DSL here that you can use, right? It's very convenient. This is an extension function in Kotlin does a nice job with BSL as well, but I love the extension function in Kotlin. And you can define one or more routes, right? It doesn't matter how many you define. And the routes have 3 criteria. They have a predicate, they have 0 to n filters, and they have a URI, okay? So the predicate is going to be something like, oh, when the request comes in to this edge service on port 9191, then if it matches that proxy path and it has the host header, spring.io, then I want to send it down. I want to say, send it to my local host 8080 customers, okay? Now the problem is that this path is proxy, but the path here is customers. So I need to change this request so that it works when I send it here. So I can use filters for this. And there's a lot of really great filters. The one that I want is to add customers. I want to set the path to be customers. And I also want to add a response header. Maybe I want to do cross-origin request scripting. So I can say, add this access control, allow origin, etc. Okay. So now I've got this very simple structure here. And we can restart this. It'll run on port 9191. Oh, what did they change recently? So 254, explore. Okay, so now in order to make a request to that endpoint, I have to have the host header. So hello.spring.io, localhost 9191 proxy, right? That's the port here. Application.properties 9191. Okay, so there's the data. It worked. And if I look at the verbose output, I can see that I have access control out origin there, right? Now keep in mind, if I change this to be, ring.io, I get 404, right? So that's the predicate matching. So this is great because I'm proxying data very easily. You can also use, you can define your Kubernetes, you can define your gateway code as property values, right? You can actually use the routes configuration here, or you can use YAML. There's a YAML definition, or if you want to pay, this is not open source, right? But you can use Kubernetes gateway Spring Cloud. Oh. Right. This is very powerful. So now you have a CRD basically for your Spring Cloud gateway, and you can define your predicates and your routes alongside your application, right? So now you can have each microservice can define their own gateway routes in the cluster. Very, very powerful. Okay, so we have a gateway. Sometimes, however, you don't want to just proxy data. Maybe you want to change the data. Maybe you want to create a new view on the data. So what I'm going to do is I'm going to create a CRM client configuration, and we'll have a component that will act as a CRM client to talk to our other microservices. And remember, our other microservices include 2 other types, right? So val ID, int, val customer ID, int, and data class customer, val ID int, val name string. Okay, so there's my CRM clients. And I'm going to create I'm going to read the data. But in order to read the data, I have to have a reactive, non-blocking HTTP client. So I'll say val, this is the syntax in Kotlin for a constructor right here. So I'm going to say, give me the web client for this, and give me the RSocket client for this, right? It's called a requester. And I need to define these two beans, these two types. So let's do that in here. Bean fun R socket. Okay. Dot builder. rr.tcp localhost. And what did we say? I think we said 8181. Okay. There's my RSocket endpoint. HTTP web client builder. Okay. So there's my RSocket endpoint client rather, and my HTTP client, and that's what I've injected here. So now we can create some views to get the data, right? So we can say flux.mt fun customers equals this dot http dot get dot URI localhost 8080/customers retrieve body to flux, and the data that we're getting back is going to be customer data. Okay, so good. That's it. This will give us a reactive stream of customers like that, and then we want to get the orders now from the order service. And so here we'll say this dot rsocket dot route orders customer ID, passing in the customer ID there, and we'll say give us the reactive stream of orders. Okay. So again, I'm taking the data that comes back and I'm just turning it into a reactive stream of the type that we want. Now, what if the service is down? What if something fails? Well, the nice thing about reactive APIs is it makes it very easy to build robust code, right? So I can do a retry here. I can say retry 10 times. I can say I want to, when something fails, I'm going to just provide a default value here. Return empty, this kind of thing, and there'll be a customer. Error resume. Okay, that kind of thing. I can say do on error. So you have a generic way of handling and dealing with errors. And this isn't specific to the web client, right? This is actually part of Reactor. So I can take that same code and put it here. And of course, this becomes an order down here, right? But it's the same exact operators. It works just fine for both. Let me clean that up a little bit. That's one of the nice things about using reactive APIs is if you get good support for building more robust services. Okay, I don't have anything happening there, so it's fine. Okay, so now I want to call the customer service and the order service, and I want to get the data back as a view of the data. So I have the customers and the orders together in one payload. So what I'm going to do is I'm going to create a new type called customer orders. Okay. That's customer orders type, and I'll say, give me the customer orders. This dot customers dot map, and I want to take the customers, and I'm going to take each customer, and I want to store the customer and the orders for that customer in memory at the same time. So I'm going to use a tuple, right? Tuple, right? And a tuple is like an array where each element in the tuple is typed. So the first item in the list is, or in the tuple is the customer itself, and then the second item will be the orders for that customer. I'll collect as a list. Okay, so now for each one of these, let me do flat map. For each one of these, I want to then take the data and turn it into a custom order type. And it will be T1, which is a, you can see this is a, well, obviously it's the customer, right? So it.T2 is the list of orders. And there we go. There's my custom orders type, my method. And notice that this is doing concurrent scatter gather service orchestration and composition. I'm calling the customer service over here. I'm calling the order service over there. They speak different protocols, but it doesn't matter because Reactive APIs makes it very clean and elegant to compose data from different data sources, different microservices. So now let's create an endpoint, okay? A simple endpoint here. CRM client REST controller, private val CRM, COs fun get custom orders. There we go. So there's my simple HTTP endpoint, so we can see the data that comes back. Localhost 9191 COs. So it gets the customer data and the orders data, right? These are part of the same payload. So I'm doing concurrent scatter gather. I'm concurrently getting all the data from the customers, and then for each customer, I'm getting the order data. But I'm not waiting for the first orders for the first customer and then doing the second. It's doing it concurrently, all at the same time, right? This is very efficient. Okay, so now I'm using Reactive APIs to create an API adapter, right? API adapter. You can use Spring Cloud Gateway to create API gateways, right? There's a problem that the reason that people create API adapters is because they often have a client that has a particular view of the data. They need the data to look a certain way so that they can use it effectively, right? And they could call this microservice and that microservice, but this means that now suddenly, because we have an RSocket service and an HTTP service and whatever, now the client needs to figure out how to translate these different protocols. That's not a good idea because now you have an Android client, you have an iPhone client, your HTML browser client. They don't need to speak 5 different protocols. They just want to talk to something. And so this is why you create API adapters. These API adapters give them a view of the data in a way that they can consume consistently in their client, right? And so this is very common. Netflix has a lot of different clients. You can use Netflix on everything, right? In this country, there are refrigerators that have Netflix installed on it, right? You can watch TV at where your food is stored. It's crazy. I mean, your iPad, your TVs, your PlayStation, your Xbox, your Roku's, your everything, right? Everything supports Netflix. So they have lots of different clients, and each client has its own special behavior for authentication, for protocols, for the language that you have to use to build the client. And so this means that that Netflix has to create lots of different services, lots of different API gateways and API adapters. And this becomes hard to manage because you want the client to have the most optimized, efficient view of the data, but you also want your services to stay clean and independent and unique, right? Otherwise, they become one big monolith again, which you don't want. And so there's a tension, right? The client wants efficient, co-located data, but the service architecture requires that things be separate and not co-located, right? And so there's some information. Whoa. And so this creates a problem. Facebook had the same problem back in 2012, so almost 10 years ago. They had the same problem as well in their architecture. And so they created something called GraphQL. Now, GraphQL is pretty popular, right? You can go to api.spacex space. There you go. You can go to api.graphql, api.spacex.land.graphql, and you can see that SpaceX, which is a company, has a giant GraphQL API, right? And and the nice thing about GraphQL is that it's a great data integration layer, right? It's also very easy to introspect. In GraphQL, you have 3 types, okay? Right here, 3 root types: queries, mutations, and subscriptions. Queries are types that return data. Mutations are types that update or change your server side. And subscriptions are for asynchronous notifications, like a stock tickers, for the market, or sensor data, or whatever, right? Something like that. So let's say I want to make a query, okay? Well, I want to make a query. I want to read data from this query for capsules, right? So capsules. And capsules, they have certain fields in them, IDs, landings, right? Well, these capsules are a particular type of data, right? So if you look at this capsule, you can see it's a type called a capsule. Capsules have IDs, landings, they have missions. Okay, so let's get the mission, right? So I want to get the missions. But notice that I can't just leave it like this. I have to specify the nested types, because it's not a primitive. It's not just an ID, a date, an int, a string. It's actually an object. So I have to specify what fields I want. So I want, okay, the name, right? But notice that I did not specify the flight, and so I don't have the flight. There's no flight information here, right? Now I ask for the flight. Now I get both. So I have the ability to get as much data as I want or as little data as I want. This is one of the benefits of GraphQL, is it's very easy to create very granular microservices that your clients can use, and you don't pay the cost. It's not slow if you don't ask for the data, right? If you want only the summary of the data, then just get that, right? There you go, no problem. But if you want the details as well, then you must wait a little bit longer, but you can also do that as well, right? This is great because now you have one client, one API for all the clients, I mean. So let's take a look at how to use GraphQL in Spring, okay? There's a project, a new project. It's not yet GA, but it's built on the official GraphQL Java Spring Boot integration. It is the next generation of that project, okay? It's being developed by the Spring team. So the people that worked on RSocket and Spring HTTP support for Spring Webflux and Spring Web, MVC, that same group of people, the core Spring framework committers, are also working on Spring GraphQL. Right now, it's an experimental project, but it's very, very good already. I would try it out at least. So let's show you how to use it. GraphQL Spring Boot Starter, M2, okay? And this is why I had to do all this work to get these milestones. You remember all the trouble I had? That's because I want to get the GraphQL version in there. Okay. So let's create now another controller, GraphQL. So we're going to say CRM client GraphQL controller. So you notice that we have controller for HTTP, RSocket, WebSockets, and GraphQL. Right? You can use the same annotation for all these different protocols so far. Okay, so I'm going to create a GraphQL endpoint. In GraphQL, you have schema. Okay, and the schema defines the types in the system. So I'm going to say GraphQL, and in that GraphQL directory, I'm going to create a schema file, GraphQLs. And every GraphQL schema has to have a query. And queries have fields, and these fields give us information. So here, I'm defining a field of type customer, which I must define here. Right, so name. This is my basic structure. This format here, this means a collection. Collection, right? This is not a collection, but this is a collection. Okay, so I'm getting a stream or a collection of customers. Okay, so let's implement this. Okay, I could do the lowest level thing. This is very low level here. run customers. This, and I'm going to use the CRM client. CRM.customers.map. And so I've got the customers, and I want to take each. Actually, no, that's it. I'll just do that. So the schema mapping annotation, I have to specify the type name. The type is query, right? And the field name is equal to customers. Okay. So this is very low level. This is the lowest level you can go. Okay, so now we go to localhost 9191 GraphQL. Okay, and here I can now issue a query. Customers, ID, name. There we go. So now I get the data for the customers. Okay, good. We've got our customer data. I don't want the name, so I just get the ID, no problem. Now, what about the order data? Well, first of all, notice that I'm creating a schema for this type called query. But like I told you, you can create lots of different types, but query is kind of important. You have to have a query in your GraphQL application. It's a convention, but it's a very important convention, right? And so you can actually rewrite that using query mapping. Okay. So here I'll say this.crm.customers. And we don't need this anymore. So the type query is specified here, right? And the field name customers is from the method. So this is exactly the same as this. Okay, schema mapping is kind of like request mapping in Spring HTTP, right? Spring MVC, Spring Webflux. It's very low level. So I want to create another endpoint here. On orders. And you can have an argument in your GraphQL handler. So I can say customer ID int customer ID. Okay, so now in order for this to work, I need to create the schema. I can say I want the orders. I'll return a reactive stream or a collection of orders, ID, and then customer ID. Right? So these are my my GraphQL types. I'm going to describe them, and I can actually, now it's expecting an argument. The argument name is customer ID. Let's go ahead and restart this. Okay, refresh this. Okay, so orders, ID, customer ID. Good, so there's, whoops. Oh, I need to provide the parameter, right? So customer ID is equal to 2, right? So I'm getting all the orders for customer ID 2. Now, remember earlier, we said that the customers, you know, they might be part of the same bounded context. And maybe it makes sense to think of them like that. And the nice thing about GraphQL is it's very easy to fix that. You can still have 2 different microservices, but you can change it so that they have the right relationships. So we don't want this orders endpoint anymore. Instead, what I want is for my orders data to live here underneath the customer. Okay? And I can very easily do this. I go here and I can say that this endpoint, it's not a quick, I'm just going to specify the customer here. I'll say customer, ID, and there you go. So now the name of the field is orders, but the type against which this is to operate is the customer. And we know that because we're injecting it here. Okay. So when we resolve the order data for a customer, this handler will be invoked. Okay. So this no longer works. And that still works. Good. I got the ID. Good. Oh, let me refresh here. Good. And then there's my order data. All right. So now we've got the customers. And oh, there's no orders. Why is there no orders? Orders. Orders. That's bizarre. Customers. Order service down for some reason. 8181. What? Did I do something weird here? Order service should be fine. Query, customer ID, orders. Customers, query mapping. Oh. That's bizarre. What did I do wrong? Customer. Customer orders, order, customer ID. I did something weird. Orders, let's see here. Is my service down or something? I don't know if I did something wrong. Did my internet just change? I'm going to restart this and see. Very curious, my friends. I don't know what I'm missing. I'm missing something obvious. It must be the late hour. I do this all the time, and it always works, so I'm not sure what I did. There's something obvious that I've missed here. I'm sorry. But anyway, my friends, that is basically a look at GraphQL. Obviously, I'm missing something very obvious. I'm sure that as soon as we are done, I'll hang up, and it'll be very obvious, just instantly, you know. Is it because of this? Orders, order. I don't know. It just seems very silly to me. This is gone, right? Anyway, that's GraphQL. It's a great fit for data integration. Normally, this thing would work no problem. So I'm missing something very obvious. I don't know what it is. Maybe I have a... still very confused by that part. Why are there no orders? What is the issue here? Edge service. What's the customer ID? I'm looking for. Oh, let's get rid of that. Okay, so I want to print out. How bizarre. I just want to see if the basic thing that I'm expecting to work is going to work. Wait, what? Edge service, orders. It's something very, very weird here. Customer, orders. It's not invoking the handler. Why is it not invoking the handler? Do I need to? I don't know. I don't know, my friends. I'm missing something very obvious, clearly. I don't know what it is, but it'll come to me when I wake up. My friends, that has been a look at Kubernetes native Java. We have looked at different ways to build applications that are meant to run in the cloud at scale and that are able to handle the complexity of building a distributed system. We looked at a lot of different patterns today, a lot of different things that you can use in your journey to production. We looked at reactive programming. We looked at R2DBC and Spring Web Flux. We looked at the Actuator and Micrometer and how to build Kubernetes probes. We looked at how to do Graceful Shutdown. We looked at how to take your application and do Kubernetes environment-specific configuration. We looked at build packs to build Docker images, and then we looked at Spring Native to do native images with GraalVM. We then looked at RSocket, which is a protocol that gets past some of the limitations of HTTP and gRPC. We then looked at how to use Spring Cloud Gateway as a proxy. We looked at how to do service orchestration and composition with reactive APIs. And then we looked at how to do data integration gateways with GraphQL. My friends, I wish we had more time, but I want to thank you so much for being here tonight. I'm sorry that at the very end, I hit some sort of bug. I don't know what it is. It's probably very simple. I apologize for that. I also, again, I'm so sorry I couldn't be here the last 2 times. I'm very embarrassed, but I'm so thankful that you were here today, and I hope you learned something from it. I'm very happy to answer questions now. And again, I wish I could be there in person. We could all be safe, of course, not sick. But maybe next time, Anyway, thank you so much.
Thank you very much, Josh.
Yeah, anyway, thank you so much.
And we have some questions from the audiences, including me. So can
Okay, I show that.
I think that Gradle is better than Maven on performance. Why do you use Maven?
Because I don't care. Like, it's the you're right. It's probably better for performance, but I care if you use Spring. That's the best. Maven or Gradle, Java or Kotlin, I don't care. Use whatever you want. It's fine. They're all good to me.
Okay. Is there a case where the process doesn't finish within the time set in time per shutdown phase? What will happen to the behavior in that case?
Oh, yeah. Your service gets killed, right? It's the sig kill. Same as before, but at least now you can stretch it out a little bit.
I see. 一応、そうか、翻訳して、30秒以内に終わらなかった、これ30秒設定してた場合に30秒以内に終わらなかったら、普通にキルしたときと同じで、強制的にシャットダウンしちゃいますということです。
はい。Next.
I'm not sure if Kubernetes has its own windows on the failed pods. Does the Spring setting override the default Kubernetes one? ちょっとこれ
Windows on the failed. No, you mean for the timeout?
I think so.
that you have to configure it twice for Spring and for Kubernetes. Maybe I misunderstood.
Me neither. ちょっとこれ質問の意味がちょっと私も取れなかったので、Windows っていうのがどういう意味で表現しているのか。
もし書き込めれば、みたらし団子さん、追加でもらえればこちら表示するんで。
He said he got it. Yes, he got it. もしなんか追加で質問したければ、もう一回書いてもらえればと思います。次行きましょうか。
Same person.
In the end, specific settings always override the default one. Env specific setting か。これはそうだと思いますけど。
一応拾った。
これは、そうですね。どこだろう。まあでも、スプリングブートの話だったら、スプリングブートの環境変数の話だったら、これはイエスですね。はい。
Okay. He answered.
Is it possible Maven Spring Boot build image for multi-module project, including some Spring Boot web app modules and some library modules? This is from me. I mean, I don't know how to specify the target project to build the image. So
yeah, I don't know. Maybe it's part of the, I have no idea.
Okay, I see. Yeah, I tried one by one. I could build the image. So, okay, I think I should do one by one.
I guess so. Yeah, that sounds very smart.
I see. じゃあ次。
Okay.
I just pasted the GitHub.
Yeah. Yes, please. I think you cannot copy and paste the URL to the YouTube comment. So I think you should tweet the URL of your examples.
Oh, okay. I will do that right now.
Yes, please.
What is the JJUG Twitter account?
Okay, we can.
JJUG, okay.
Yeah, we can retweet it.
All right.
Maybe that's all.この他質問があったら、皆さん質問書き込んでください。まだ時間あるのでよかったらどうぞ。特にないかな？
大丈夫かな？
大丈夫かな？終わりにしちゃうよ。みんないいですか？
大丈夫ですかね。じゃあ先になんかアナウンスとかあればやっちゃいます？
そうですね。皆さんが質問を書き込んでくれてると信じている間にアナウンスしたいと思います。JJUGまず最初に今月末にJava17 リリース記念イベントを開催します。9月の29日です。多分今ツイッターで誰かがハッシュタグをつけてつぶやいてくれてるに違いないと思うんですけれども、9月の29日にJava17 リリース記念イベントを開催します。今回は以前来てもらった FooJ という OpenJDK のコミュニティと一緒にリリース記念イベントをしたいと思いますので、一つは、インドの方の英語セッション。もう一つは、日本語で西川さんの 日本語セッションという感じで、Java17 を英語でも日本語でもお祝いしたいというイベントになっておりますので、皆様ぜひふるってご参加くださいというのがまず1つ目。で、2つ目、ナイトセミナー系だと、次は10月ですね。10月のイベントは10月の頭の方、ちょっと日付決まってましたよね。ちょっと待ってください。10月の、いつだっけ ?10 月の8日かなちょっと忘れちゃったんで、今喋りながら調べますけれども、10月にですね、また海外からセッションスピーカーを呼びつつ、日本語のセッションも一緒にやりつつという感じで、日本語と英語のセッションが1本ずつの、セッションをやります。一つは Java チャンピオンのカークさんですね。スピーカーの方がわざわざ書き込んでくれました。で、日本語セッションの方は日本人の Java チャンピオンの坂田浩一さん、塾長さんですね、の方で、セッションやってもらいますので、皆様お楽しみにと。こちらまだイベントページ出来上がってないので、イベントページ出来上がり次第ご案内いたします。10月7日です。はい、皆様、ふるってご参加ください。あと、JJUG CCC が11月の、誰かちょっと待って、パソコンが固まって日付が見れないんだよ。誰か、11月の23だっけ
OS 使ってんですか？どこの会社の OS 使ってんですか？
ちょっと Windows ってやつなんですけどね。
JJUG
CCC の 21?
カレンダーに入ってなかったな。多分21です。
21ね。21日に JJUG CCC 2021フォールやります。もうすでにスピーカーも決まって通知が出てますので、スケジュールが出てくるのは皆様お楽しみという形でお待ちください。こちらも塾長さんからコメントいただきました。11月21日で正解だそうです。はい。です。と言ってる間に質問が1個出てきましたね。ので、こちら共有します。
We have one more question.
Yes.
Yeah, little abstract question. I'm beginner for reactive programming, so I don't know about that pros and cons. What is its pros and cons?
3 big benefits. I talked about them earlier. Before I continue, though, I fixed it.
Okay.
Schema mapping. Here's the order data. Anyway, okay, so there's 3 benefits, right? One is efficiency, so it reuses threads effectively. 2 is it gives you one data type called a reactive stream, a publisher. And these, because you have one data type, it's easy to describe different kinds of data. So if it's data from Kafka or RabbitMQ or WebSockets or GraphQL or RSocket or a SQL database or whatever. It doesn't matter if it's asynchronous or synchronous, small or large. You have just one type of data. And this makes it very easy to compose that data, to put it together, right? This is very important in the world of microservices where you have lots of different data sources that you need to integrate and to glue together. Now, when you write microservices without reactive APIs, a lot of the work that you do is taking different data APIs and changing them and gluing them together and adapting them. You don't need to do that anymore. Life becomes very simple. You have one type of API, reactive streams. And then because you have reactive streams, just one API, one type, then you have a third benefit, which is now you have a single place to add operators to support retries and circuit breaking and other things like that that make your code more robust. One very important thing that you get is back pressure. This is the ability of the client to tell the producer of the data that it cannot handle anymore and to slow down, right? So 3 benefits,
Efficiency.
Resource efficiency. 2, one type, one abstraction. And 3, robustness, these patterns to make your code more robust.
はい。一つ目、大丈夫分かったような気もするんですが、はい。一つ目が効率性で、スレッドを再利用するので、 スレッド再利用というか、一つのスレッドで複数のリクエストを扱ったりできるようになるので、リソースの効率がすごく良くなります。で、2つ目が、One Data, One Type。これ、リアクティブストリームズというか、スプリングクラウドストリームを使うメリットの一つでもあるんですけど、いろんなデータソースに対して個別に、そのデータソース固有のデータクラスを作ったりだとか、あるいはそのリストの代わりになるものだとかを作る必要はなくて、接続先が何であっても、もうフラックスともので全て扱えるようにすることで、たくさん型の変換とかを書かなくて済む。同じ型で、複数のデータソースに接続できるし、ネットワークも含めてですね、接続できるっていうところのメリットがあります。で、3つ目が、堅牢性、ロバストネス、堅牢性ですね。で、例えばリトライとか、バックプレッシャーの説明をするとあれなんですけど、この、受け側が、このもうリクエスト受け付けられないとか、うんぬんとかの設定を、一箇所に固めることができて、それで、接続先を、問わず、なんと言えばいいんだろう。接続先を同じ設定で使えるので、堅牢性が高まりますという話でした。
大丈夫そうです。理解してますと来てますので。はい。みんな、もう質問はいいかな？良さそうですね。もう来なさそうな感じよね。
はい。
はい。じゃあ。
大丈夫です。大丈夫なんですよね。では、今日の、JJUGナイトセミナー、これで終わりたいと思います。Thank you, Josh. We will finish the seminar tonight. Yeah, that was a great session, and I learned some about Kubernetes, and I have to rewrite my POM XML and some GitHub Actions script to use the Spring Boot build image command.
Cool. Yeah. Wonderful. Thank you so much for having me. I hope we can do this again soon. And I'm so sorry for.
Don't worry.
Time. I'm sick. I really wish I felt ashamed. I'm very, very embarrassed. But I really appreciate everybody. Thank you.
Yeah, we appreciate too. And I hope you have another session in the future, in the near future.
Me too. Thank you very much.
Thank you very much.
Have a great night.
Bye.
Or evening. Yeah.
女子が先に落ちた。